So a small information, this webinar will go on recording, and I would be uploading to the common location and would be sharing once the webinar is completed.
صباح الخير يا عسل، كيف صباحك؟ إن شاء الله أنت تمام. أنا هسه في ويبينار موجود عن ساعتين بحضره ورد عليك.
So it's almost 8 o'clock. Do you want to start, Harish, or can I go ahead?
Hey Chakra, we can go ahead.
Okay. All right. Hello, everyone. So my name is Chakradhara Rao. In this webinar, we are going to cover some of the basic concepts of Docker and as well as OpenShift. So I want to keep this webinar interactive, so feel free to unmute yourself and ask questions whenever you feel like asking something, so don't hesitate. And also, I'll be giving some of my contact details here in the slides, so you can reach out to me after webinar if you have any questions on whatever topics that we discussed today. And so thanks, Harish, for hosting this. With this, we'll go ahead and start the webinar. Do you want to hit the record button, or is it already recording?
No, it started.
Okay. All right. So a brief introduction on what I do. I'm a solution architect, basically, for a company called Red Hat, specialized in container technologies. So on a day-to-day job, my job is to go to companies and then educate them on containers and what are the advantages that they get when they use containers for their production workloads. So I came from a programming background. I used to do a lot of Node.js stuff before I went into Docker and any container related technologies, mostly on Node.js and NoSQL databases. I also did some mobile app development, mostly on Hybrid and a little bit of Android as well. I've been working on Docker for about 2.5 years now, not to the Docker company, but Docker technology. These are my GitHub and Twitter account. If you want to reach out to me after this call, if you have any questions on Docker containers, you can definitely reach out to me on those contacts. With that, we'll jump into the agenda. So in today's session, we are going to cover some of the basic concepts of what a container is and what is Docker and what it has to do with containers, and why we need to use Docker in a container technology. So we'll touch base some of the fundamentals of containers and Docker in general, and then move on to some of the orchestration concepts around containers, like how do you scale your containers to a production level scale, and also how do you make sure you stitch all your containers together to make it like a cluster. Okay, so we'll dig into some of the concepts of OpenShift and also do some demos on top of it. Okay, so this is what we have in the agenda. Question and answers, you can jump in anytime during my session to ask any questions you have, or you can put in the chat window and Harish can look at that chat. With that, we'll jump into the main agenda now. So what are containers, and what do we mean by a container when we say Docker container or any other format container, what exactly we mean. So let's take the example in case of the left side one. You have a VM, right? So for a basic user, containers are like your VMs, but very lightweight. Let's say you can deploy 3 VMs for a host. You can deploy like 100 containers per host, whatever, with the given configuration. Let's say it is some 16 gig machine, 16 gig memory machine, and 4 CPU. If you can deploy 3 VMs of your application, you can actually deploy about 10 times that number when you go into container world. So we'll try to understand what is the fundamental difference between a container and a VM. So we need to understand how VMs work and then how containers work. So if you look at the left side of the page, you have your server at the bottom, and that's your physical hardware. And on top of it, you have your host OS, which may be a Red Hat Linux OS or any OS, right? Host OS. On that, you have your hypervisor, maybe your VMware hypervisor or KVM hypervisor. And on top of it, you have your different VMs, application VMs, with their own guest OS. Maybe your VM is running on Red Hat Linux or CentOS or Ubuntu, whatever it may be, your guest OS is. So in this VM-based world, like maybe a decade ago, when VMware came into picture, it has changed a lot it has changed a lot of architecture in how we deploy applications. Before that, it used to be bare metals. Bare metals are good, but they did not provide the flexibility of deploying multiple applications, which share maybe some of the common libraries with different versions. It is pretty difficult to deploy those kind of applications on a bare metal. So utilization of bare metal resources has become a challenge. How do we deploy multiple applications? We need to deal with port conflicts. We need to deal with version conflicts of the binaries or libraries that each application uses. So we are kind of limited on what kind of how many number of applications we can deploy on a bare metal. So we entered into a VM world where you can run multiple OS on a particular hardware, physical hardware. But the catch here is every time you create a VM, it creates a different layer on top of it. So you have your host OS, then there is a hypervisor, and then there is a guest OS as well. So you're kind of repeating 3 times OS that you need. So instead of running it on host OS, you're actually having 3 times the number of OS you should have for application to be running. So you can see it in here. You have guest OS, hypervisor, and host OS, 3 times what you need, which is to a certain extent okay. Back in the world VM world, it is okay. But if you want to really utilize your hardware efficiently for applications, you need to have get rid of these extra layers like hypervisor and guest OS to make it to utilize your resources well. And if let's say you are using your application A and B are using libraries, a different version of same libraries, you have these libraries also replicated here, okay, on each level. Whereas in container world, what happens is you have your bare metal server, that is your physical hardware. On top of you have a host OS, which can be a Red Hat Linux OS or a Atomic OS. And on top of it, you can deploy your applications just like VMs. These all applications run they look like a VM, but they are not really VMs. These are controlled processes on top of your host OS. So these are actual processes. When you say container, this is actually a container process that is running on your host OS. So it's not really a complete full-blown OS. So how does we achieve this level of granularity? How do we achieve this level of efficiency in hardware? So containers were there in like maybe from 10 years. Google has been using containers from very long time. Actually, whenever you open a Gmail session, you are actually spinning up a container. So Google spins up about 3 billion containers per week for each for Gmail and their Google infrastructure needs. So containers are not new. But what Docker has done is it has done a very good job of making it look easy for developers to consume those containers. So instead of containers being a job of big corporate companies, when Docker entered into the picture, they made containers available for general developers to consume with a good layering technology that I'm going to discuss in future slides. But with containers, you can actually get more efficiency on your hardware. So how is it achieved? Each of these process or container on this OS is controlled processes. So the resources this app A process can it cannot really go and mess with the other container processes what other containers are doing. So each of these processes is controlled using SC Linux and also C groups. So C groups in Linux are basically control groups. So what control groups does is it can restrict how much a process can consume memory-wise and also CPU-wise. So how much that process can consume on resources, and also what that process can access. So is it limited to only a set of file system that it creates, or it can go and talk to the other file system as well? So it can. So the C groups can basically control what a process can do. So in that way, you think that each process is a container or a VM in itself, and you get some kind of VM like structure. So each process here, the app A, app B, and all other apps that got deployed here, they behave as though they are like VM. So they have their own network namespace, like they have their own IP, they have their own file system, they have their own user namespace, network namespace, all of these. So all of these are achieved basically using the C groups and chroot inside Linux. So as of now, you can have Docker containers only in Linux systems. Although you can run Docker daemon on your Windows machine, it doesn't really mean it's creating machines on your Windows host. So it's creating a small virtual machine, which is a Linux virtual machine, very small one, and then on top of it is creating containers. So this technology is available for any Linux kernel which is above 3.10 kernel version. So whichever OS that is greater than 3.10 kernel Linux kernel, it supports Docker containers. Okay. If you ask me what kind of OS you want to use for testing this out, I would suggest to go with Red Hat 7.2, 7.1, anything greater than 7 Red Hat versions, or CentOS 7 plus versions. Okay. So, are there any questions on how? What do you mean by containers on a server now? So you can put it in chat window if you're not able to talk, or you can unmute yourself and talk. Both are good. So there is a physical server. On top of it, there is a host OS, maybe Red Hat OS, and on top of it, you have different containers that are running. So again, like I said, these containers are nothing but processes. That is why we are able to achieve a bigger density when compared to VMs. And the good thing is, the app A can be of a one kind of OS, and app B can be one kind of OS. So app A can be Red Hat Linux OS, app B can be a CentOS based application, and if we have app C, it can be a Ubuntu based application. So it doesn't really matter. All it needs is the correct version of kernel that is running in the host OS. And all these containers will share libraries which are present on host OS. You can add your own libraries to applications. So let's say app A is Node.js 0.1 version, and app B is Node.js 4.0 version. So you can run two Node.js based applications on a single OS, just basically by choosing a different kinds of library sets from base images. So I'll go through what a base image is, what are we talking when we say base image in next few slides. But understand that these applications can come from different base OSs, which can be CentOS or Red Hat or Ubuntu, whatever it is. Okay, so this is what containers are. With that, I'm gonna dive into architecture of what Docker is, and then give some demo. So you have server, host OS, and there is a Docker daemon. So I'm going to discuss what a Docker daemon is in next slide. So let's switch to the Docker architecture. Okay, so this is a Docker architecture. So Docker is a technology which enables containers on your host, on your OS. So Docker is kind of a format that you use for creating containers and run on your host machine. So you might have heard of Docker a lot in the recent days. It has started, I think, about 3.5 years ago, but it has gained a lot of momentum in past 1 year. And it is, if you look at the GitHub commits and the open source involvement, it is one of the topmost open source project out there in the world. Okay. So what Docker has done is a good way of containerizing your applications. A Git-based method to basically organize your layers of images. I will go through some of those concepts, but let's dive into the architecture of Docker. So what does Docker contain when we install Docker for Mac or Docker for Windows or Docker for Linux? Okay, so Docker architecture contains a Docker host. So this is your host. It can be your Linux host, or in case of Windows, it is going to create a virtual VM, which is lightweight virtual VM on maybe using a VirtualBox or a libvirt, and or on Mac it uses hypervisor like Mac native hypervisor. On Windows it uses Hyper-V, I guess, and that's the Windows native hypervisor. We need to check on the name, but it uses based on what kind of host OS it is using. So it's going to, the Docker host is typically a Linux OS, okay? And when you install Docker, it's going to install a Docker daemon. So this is a daemon process that runs always and looks for commands from Docker client. So this Docker client is basically a exe. So with this exe, you are going to connect to the Docker daemon and then run different commands. Okay. So typically your client is a exe where you do the development activities, and your Docker host can reside on the same machine or on a remote machine. It doesn't really matter as long as client is able to communicate with the host machine. Okay. So what does Docker daemon do? When you ask, so this might be confusing in the beginning, like what is Docker build, what is Docker pull, Docker run. I'm going to demo all this stuff, so don't worry about it. For now, understand that we are running some command related to Docker, building an image. And when you run these commands, it's going to contact the Docker daemon. And then Docker daemon will basically, based on what you run here, it's going to create images or containers. So images are like your classic class files, and the containers are like objects of those class files. So let's say this is a Redis image, right? This Redis image is a binary, so it's like a storage. And when you run this in binary image, it becomes as a container. So it's like a class, and this is like an object. Okay. So you can have one class, but as many containers, as many class objects as you want. So that's how it works. I'm going to demo you. I'm going to show you what it is in real time. But understand that Docker daemon is going to, based on what commands you're executing, it is going to either create Docker images or Docker containers. Okay, and sometimes you need to fetch these images from a registry. You may not build everything from scratch. You may use some of the base images out there and then build on top of it. So let's say you have a CentOS image. Okay. On CentOS image, you want to install a Node.js application, Node.js runtime, and then on top of it, you want to install your Node.js application. So you won't create the Docker file, Docker image related to CentOS. You just you just want to deploy your application, putting into that. So it might use some of the resources that are already available. Those are available in the registry. So the default registry for Docker is hub.docker.com. Let's go take a look in the hub.docker.com. So this is like your artifact tree. If you know Java, this is like your artifact tree. Or if you know npm, this is like your npm registry for Docker Hub, for Docker images. Okay. So in npm registry, you go and fetch npm modules, whereas in hub.docker.com, you go and fetch Docker images. Okay. So if I go click here and then search for, let's say, Node.js, or click on explore here, there are different images that are available in Docker Hub. So Nginx, Mongo, Redis, MySQL, or Node.js one. So since we are a Node.js fanatics, we'll just go check on what kind of Node.js images we have. So right from 0.10 version to 6.5 version, we have all the Docker images for each of these Node.js versions. So if you have a requirement like I need to run multiple versions of Node.js applications, you don't need to install all versions on your machine. You can just use a corresponding Docker image and then get started from there. Okay, so as easy as that. And if you want to run multiple Node.js version applications on same single machine, you may not be able to do it in one go, right? So you can, when you're using Docker images, you can do that piece. So I'll show you how to do that. You will get a better understanding when we do a demo. Let me check for some chat messages if we have any questions. Otherwise, I will continue. All right. I see some chat. So, is it possible to set up Docker in Windows machine? Yes, it is possible. Ashok has given. Thanks, Ashok. That's it. No other questions. I'm going to continue. So, that is Docker Hub. It's like your npm registry for Docker images. I'm going to share this slides after the call. Okay, so with that, we'll jump into Docker demo. So I have how do we install Docker for Windows or Mac? You just go to docker.com. Just type in Docker for Windows or Docker for Mac. Okay. If you have Windows, just hit this button. If mine is a Mac, so I'm going to hit Mac, Docker for Mac, and then click here. This is just a simple exe that you need to run if it is Windows. If it is a Mac, it is DMG. So Docker for Mac. So there is another one called Docker Toolbox, which is kind of outdated. So don't use that. You can use Docker for Mac or use Docker for Windows. Let me see. Okay, so take this URL and then just download the exe. You run that exe. That should be it's a seamless installation. You don't really see any issues. Okay, so once you have installed, you will see this little button on the top, and it says Docker is running. So that's when you know that Docker is running fine on your machine. If you don't see this Docker is running, try to debug why it is not running. Okay. And few more things. When you have installed Docker, it should also install a command line tool called Docker. This is called Docker. Your client in the architecture, whatever you see is a client, Docker client. Okay, so you have your client and you have your server. So my client is 1.12.1. My server is also 1.12.1, which is good because they are on the same version. Okay. When my Docker is running, I just do Docker PS to see if anything is running. So I don't have anything running on the machine. So PS is the commands are similar to what you have in the Linux. Okay. So keep that in mind. So now I want to run a MySQL instance or a MongoDB instance or maybe some Node.js container on my machine. What I do is if I do Mongo, it's not connecting anywhere because Mongo is not installed on my machine. Okay. So what I'm going to do is run a Mongo container that should spin up a MongoDB instance on my machine, and I should be able to connect to that Mongo. Okay. So I do Docker run Mongo. Okay, and then hit enter. So this will go fetch the Docker container because I already have the container downloaded on my machine. It's pretty quick. Otherwise, it would just pull the Docker image from the Docker hub, and within a couple of minutes, you should be able to see this thing. So you see, it has started a MongoDB container, right? And it is waiting for connections on 27017. And this is something running inside a container. It is not running on my host. Okay, it is running on my host, but it is a controlled process which is running inside a container. So understand the difference. So I'm not really installing on my host now. It is running inside a container. So how do I check that? So I keep this running and then open another window and I say Docker PS. You see that there is a container that is running here. So Docker PS and the container ID is this one. So when I inspect that container, I also see a IP address assigned to that. Okay, so it gives a lot of information. I'm going to get only IP address from the output. So it has given me an IP address that it is 172.17.0.12. So on my machine itself, I got a virtual machine kind of environment, whereas this has everything for it, like its own names, its own network namespace, its own file system, its own ports and all. Okay, so how do I verify that? I say it is running as a container, but how do I make sure that? Okay, so we take a look here. It says MongoDB is initialized. Okay, on my current directory, I'm in users Janagam Hyderabad meetup. I want to go inside that container. So Docker PS, and I do Docker EX ec docker exec minus it and give the container ID here and give some command for enter like bash or sh. Okay. So right now I'm inside the MongoDB container.
Hello, Chakradhara.
Sorry.
Yeah, there's a delay. There's a delay in whatever you're typing. So can you please hold on for a second?
Sure. Do you see? Can you tell me what do you see now?
Right now we are seeing docker exec space it. That's the command that it's still typing in. So we are seeing that.
Okay, sorry about that. So what essentially I'm doing is I'm getting inside the Docker container by doing a exec command. So docker exec minus it means interactive mode, and then give the container name and give a command that is bash. So it enters into the container. So you see root @95e8be. Do you see that?
Yeah, we see that now.
Okay. So I'm inside container. Like if I do pwd now, it shows root, and if I do a ls, so it has got its own file system. So which is like your VM, right? You actually have a VM now, but which is very lightweight VM. So let's see. Whatever I do in this container is ephemeral. It won't stay when the container is killed. So it got erased whenever the container gets killed. So it should run a process. I'll show you by coming out of it. Let's see. You have your Mongo running inside it, and I'm able to connect to that Mongo instance. Okay. And if I look at the print env, it says my host name is this one. The Mongo version is 3.2.9. All this stuff. Okay. So I'm inside the container. Yeah.
Yeah. One quick question. So we have downloaded Mongo, but how come we are able to run the Linux commands on this? So Mongo is bundled with some other OS, and it's downloaded and it is installed. So is the reason we are able to run the Linux commands on this?
Yes. So if you are using Windows, when you install Docker for Mac, it installs a virtual machine, which is a Linux virtual machine, and then installs Docker daemon inside it. So you are not actually using Windows there. You are using a virtual machine and then running commands inside that. Is that clear?
So in case of Mac OS, so still in case of Mac OS, when we install only MongoDB image, and when we run into that particular container, we still are able to access the host related commands. Am I correct?
No, not really. So the host is isolated now. You are inside container, and all your if I say ls/root now IP bin boot and all of this. If I do ls/home, you see that there is nothing inside the home directory. Okay. But if I open another session which is on my Mac, if I do ls/root, I got all these applications and all of these. And if I do /home, let's say I'll create something in the home directory. mkdir/home test. Let me put sudo there.
Actually, there's too much of lagging in between the video and the audio. So that's the reason, like, there's too much of lagging between. Sorry.
You have lag?
Yeah.
Okay.
Because of the bandwidth, since there is a rain in Hyderabad, also the most important thing is bandwidth differs from one person to one person. Anyways, let's continue this. And
Okay.
the webinar session will be available on social. It will be packaged as an MP4 and it would be stored onto a common file, so everyone can refer to it.
Okay. Yeah. So let's look at the SP folder. On my Mac, if I look at SP folder, I have all of this stuff. Okay, lot of files. I'm going to wait for some time, and then if I switch back to my container and do a SP on my container, it doesn't have all these. It has only related to what is needed for the Linux or Linux. So it doesn't really have anything that I have on the Mac. Okay, so it has created a file system for itself, and then it is actually acting as a VM, which is nothing but just a single process that is a controlled process. Okay, so from this, what we understand is we can actually treat applications like they're running inside their own VM, very lightweight VM, which are nothing but actual processes on your host. So with that, we can run a good number of applications on your host without any issues. Okay, let me try to switch to a different network. Maybe if the network issue is on my side, let me try switch to another network. Okay, give me 1 second, please.
Hi, Chakradhara. Can you hear me?
Yes, yes.
Yeah. Can you just switch over to the Docker so that so that you can find the Linux what has been running inside the Docker. So you can just cat /etc/
Yeah. So you want
can
me
you
to
just
paste?
go into the inside the Docker host? I mean, what you call?
Yeah, I'm inside the Docker host.
Yeah. Now say cat.
Cat.
Yeah. Space -etc. Yeah. /* release.
So you want me to output the release version?
Yeah. So that you will know, I mean, the Linux installed on the machine. I mean,
Yeah. Okay.
Yeah, start.
So I just captured
No.
the SP host release, OS release.
Yeah, no. Yeah, start. No. Yeah, OS release. Okay. That is, the Debian GNU Linux. So this is the virtual machine on which the MongoDB is running. So this is running on top of Mac OS, as you said, on the VM.
Right. Yes.
Yeah. Right.
Okay. Yeah, that's a better way of showing whether we are running it in a different OS or not.
Yeah. Exactly.
Thanks for that.
Yeah. Thank you.
So can you see my screen now? Is it good? Is it getting updated?
It's better now.
Okay.
Docker PS is the Docker PS is the command that you just ran.
Yeah. Okay. So yeah, I'll limit the number of demos today, maybe just to get rid of this lag issue. Let me connect on a different network, try to see if it helps. Can you see my screen?
Actually, it's good, Chakradhar. Like, I'm able to, view the presentation good. I think there might be some connection issue because it's raining outside. There might be some, network issues and all. So,
Hey Chakra,
So there will be
The whole issue
yeah.
could be personal, individual bandwidth internet. So let's not worry.
Yeah.
Since we are recording this thing, let's go ahead and do what we can do. If there is any delay to the participants, apologize us. There would be a recording version of the webinar. You can I will be distributing it to you once the on the meetup group and on the WhatsApp group the location so that you can go and refer to it.
Yeah, thank you. That sounds good. Let's go ahead.
Yeah, Chakra, please go ahead. Oh, the presenter went on offline. Let's wait for a couple of minutes because he's switching over internet connection.
Sorry, I hit the disconnect button accidentally. Can you see my screen now?
Chakradhara.
Yes.
Yeah.
Hello?
Yes, we are.
Okay. Let's go forward then. So as I've shown you, we were able to run MongoDB instance on the host, like a Linux container. Let's go try MySQL one now. Okay. So Docker PS, I see MongoDB is running. So I want to run Docker run MySQL.
Hey Chakra,
I would like to run it as
your screen is frozen on the previous command. We're not able to see anything further on it.
Oh, okay.
The same Wi-Fi, we're not able to see.
Okay, let me switch back. Give me 1 second, please. Can you see now?
I think we all need to log in again.
No. Wait a minute.
Because I think yeah, now it's reflecting. Yeah.
It's okay. My screen. It's my screen. Give me a minute. I'm just changing on.
Yeah, I'm on it now. So let me know if you face issue again. This time I want to run a MySQL instance. I've run already my MongoDB. If I want to run MySQL instance, I'm going to do.
Like we are not able to see the screen.
Oh, give me 1 second. Maybe I'm not sharing the screen.
Yeah. It is saying that waiting to view Harris Choletti's screen.
Can you see now?
I think 1 sec. Like I will again log in and see it's able to connect to the new session.
No. It's the same session.
Chandrasekhar, you have to share your screen again. Just check your screen cache settings once again.
Yeah, I just did share my screen again. Okay, sorry. Maybe that's the issue.
Chakradhar, it's the whole issue is you seem to be offline.
Oh, I see that stop sharing option on my GoToMeeting.
Can you stop sharing and restart sharing?
Okay, I'm doing that now.
You're still offline.
You're still offline. I think. Okay. Can you once the web session and then rejoin?
Chakradhar, actually you connected with 2 names, right? One is with Chakradhar and another one is caller 1.
1 second.
You're talking on caller 1.
Now I have. Yeah, I've made you present. Now your screen will be visible once you say once you share your screen.
Okay. I did.
Yep, perfectly working well.
Okay.
Now this is through web. Okay. Yeah.
Sorry guys. Okay. Yeah. Now you can go ahead.
Yeah. All right. Thanks. So this time I have run a MySQL container. So all that you did is Docker run -d MySQL. -d means in a daemon mode. So that will run on the background. So if I do the Docker PS again, so it has not started the MySQL instance because there are some reasons why it did not start. So put a -a here, and it will show you all the containers that are run and dead. So PS only shows you what is currently running. If you put -a, it shows which are exited also, which are dead also. Okay. So this particular container exited about 1 minute ago. If you want to see why it is exited, just copy the container name and then do docker log and give the container name. So it says you need to specify MySQL root and all these passwords, environment variables. Only then it will run the command, because when it is starting the MySQL container, it needs to know what root password it needs to use. Okay. So the next time I run docker run -b, I'll put environment variable injected injected into that. So -e means environment variable, and I choose a random password. Okay, let's say password, and I can choose any one of these. So -e password, and this should run the Docker container now. If I do a Docker PS, it shows it is running a MySQL container. Okay, and if I do Docker inspect on this container and look for grep for IP address, it shows this is the IP address. Okay. Now I can connect to this MySQL instance, put -h, give the IP address, -u admin, and then -p, that is password, database. This is a command you can use to basically connect to the MySQL instance which is running on your local host. Okay. Does it make sense? Is that clear?
Yeah, please go ahead.
Yes, it is clear.
Yes, it is. Please
So
go ahead.
yeah. So you can basically connect on this IP address. It treats like it has its own VM, right? And after that, I'll show you how to deploy a Node.js application inside a Docker container. Okay. So I'm switching to my repo. Okay. I have an example called Node.js here. So how do I have a Node.js application, and how do I make it a Docker container? Okay, so that is a demo that I'm going to show you now. So to make an application, maybe it may be a Node.js application, or it may be a Java application, or it can be any languages. All that it needs to have is it support for Docker, support for Linux. Okay, so if that app can run on Linux, you can pretty much make that application run on container. So in order to do that, you need to write a Docker file. So the Docker file is a constant file, like a standard file that Docker daemon looks for and builds a Docker image. So if you go take a look in the repo that I've created, this one, it's in the Node.js folder. So I have 3 files here. The one is a Docker file, the other one is package.json, and there's a server.json. So let's go to take a look in the server.js. In the server.js, I have nothing. It's a simple Express app, which is saying hello world every time, and is running on 8084. Okay, this is my server.js app. And in the package.json app, I have a mentioned Express dependency, which is 4.13.3. And the start command as node server.js. This is typical any other Node.js application. So now there is nothing new in that. So the new command that file that you look at is Docker file. This is a standard Docker file that you need to edit to make your application a containerized application. So what does it say? The first one is called, the first statement in any Docker file is called from. So this is a constant. So what it does is, from this base image. So what is this base image? It's a node Node.js based base image, and argon is the version. So what does it mean? So this image is again a Docker image. So this is again a Docker image, and there is some definition available on the Docker Hub. So let's go take a look in the Docker Hub. What is Node.js Argon? Let's go to take a look in the hub. There's a Docker Hub, right? This is where your images, this image is stored. So if we go, come take a look here, Argon, in this repository. So what is this image? Again, some base image based on Ubuntu here. We can have CentOS based base images also. And on top of it, it is installing Node.js. Okay. So this Node image, this base image already has Node installed. So you don't need to install it separately. So that is advantage to use Docker containers. So you have some specific version of your Node already there inside that image, and you're writing your application on top of it. In the same way, you can use you can use a different version of Node. So let's say you want to use 0.1 version, you can do that. So you, instead of using Node Argon, you just put Node colon 0.10. So that will use Node.js 0.10 version instead of 4.5 version. Okay, as simple as that. And on top of it, you're basically running some commands. This may be like your similar to what you have in the shell script, right? You're going to create one folder, work dir. So these are all standard keywords of Docker. And then copy your package.json, which is available in the current directory, to this particular folder, and then again copy So once you are done with this, so that you get when you layerize all these things is, if your app is, let's say there is another app which is starting from this step 4, so you can actually use this layer as the base layer and then run all other next steps custom to that application. So it will reuse all those layers while it is building the application. So the amount of memory that you consume, or the disk space that you consume, will be very less when you use this layer structure. So like I said, containers were there from decades, right? Like Google has been using it from a decade. But what Docker has done is do some nice layering stuff like this, and make it very user friendly for developers to consume that container technology. So this has been done by Docker. So if you look at the layers here, so this is one layer, this is another layer, and copying the file is another layer, and doing npm install is another layer. So it does the npm install there and then do that. So if I look at Docker images, it has created a Docker image called Node.js app. So the Docker image is about 651 MB in size. Okay, and the base Argon image is about 677 MB. So on top of this base image, it has built a Node.js app application image. So this one is about 647 MB, and this one is 651 MB because it's going to install Express, maybe do some copy stuff and all, right? So it has added some MB of layers on top of it. Okay. Once the Docker image is ready, you just do similar to any other Docker image. You just do Docker run -d to run it as a daemon, and give the Docker application image name. I'm putting a -p parameter here to expose the 8080 port onto local host. So I want to expose the container port 8080 port, tag it to any one of my host port, so that way I can go and access on my host. Okay. So if I do this Docker run, it runs it. So this is a container that got run. If I do a Docker PS on this, Docker inspect on this, and grep for IP address, I get 172.17.04. Okay. So I do a Docker logs on this. So you can look at the logs, right? So it has started Node.js, it has started the server.js, and the application is running on 8080 port. So application is running on 8080 port of the container, not your host application, not your host OS. Okay, so if I do Docker PS, you see that the Docker container 8080 port is forwarded to 32768 port of the OS. So whatever you run inside container port 8080 is getting forwarded to this particular port. So you can go and hit this container this port to see what is this application serving. So if I go copy that 32768 and then HTTP localhost, give that port name, it shows hello world, right? So this is actually served by container, this is not running inside on my host. Okay, the same thing happens when you install. Yeah.
Hello. Can we run with the Docker IP address also, right? Like the Docker IP address is 172.17.0.4. Can we run that one also, right? Directly
yes.
on the browser. Yeah.
You can run directly from the browser. This has been enabled in Docker for Mac, but if you are using boot to Docker, you will not be able to run it. I'm showing this port forward for a reason. I'll explain you in the next few sessions. But so you can port forward, or you basically directly hit the container IP address, like I've shown on the URL now. So if you do a curl and on that particular host, it should be able to reach it without any issue. Since we are using Docker for Mac, yeah, this is where things get delayed. So if it is a pure Linux OS that you're using, you can definitely use direct IP address. But if you are using Docker for Mac, your Docker on a Mac or a Windows, then it is better to port forward that to your host port and then access it from there.
Okay.
Because you might run into some issues basically. Ideally, it should go and hit this, but it's not hitting it. It's some issue with the Docker for Mac. But if you port forward it to a host IP host port, you can go and definitely hit that. So you see that running here, right?
Yep.
Okay. So in theory, you can run as many number of applications as you want just by hitting this URL, this command. So Docker PS, it's running 3 apps now of the same application. Okay.
All are running applications, right?
Yes, all of them are running now. So 32770. If I go hit this, oh, sorry. So it is the same output here, and if I do this as well, it is again same output. So you can run as many Mongo instances or as many MySQL instances based on your resource anyway, but you can run basically number of those instances, multiple instances of your application on the same node without worrying about the port conflict. So
Chakradhar, I have a doubt here.
yeah.
Docker is a container-based application which uses our main operating system resources. On top of it, it will build containers, right? Am I right?
Correct. Right.
Yeah. Okay. In that case, we built all these containers which are running on your machine right now. Can we have a visual application like if you want to go to that container, what you are doing, you are just getting into that container, and then you are entering your commands on that machine, on that container machine.
Yes. So if I do
Am I
Docker
right?
exe, yeah,
Yep,
if I do Docker
I got
exe,
it. Can we have a UI like if we have virtual it is also a virtual machine. You can feel it. Instead of command line, can I use what can I say?
Yes, I understood what you're saying. Some kind of UI to interact with the container,
Yep.
right?
Yep.
So that is when OpenShift comes into picture. So OpenShift does a lot of this, giving a UI perspective for containers, and also some of the orchestration aspects. Like running one container is okay. You can run like on a single Docker host you can run, but if you want to run these containers on multiple hosts, how do you make sure all these are connected together? How do you make sure there are no port conflicts with the host? So there are a lot of other pieces that comes into picture which are taken care by OpenShift. So that's in our next session. I will cover some of the concepts on OpenShift, like how OpenShift takes care of all these problems for basically dealing with containers.
Okay, thank you.
Okay, yeah. So for now, it's of more of command line, but as we progress, I'll give you more details on how you basically do these pieces inside UI also.
Okay. Okay.
So
thank you, Jacob.
Yeah, no problem. So if you see, we have three containers that are running for the same app. But if you want to load balance this application, right? Like this application is running 3 instances. If you want to load balance this, you have to do it manually. Like you need to put some kind of HA proxy or Nginx in front, and then define a backend, then define a front-end port which does the load balancing, maybe round-robin load balancing to these applications. So these are all manual activities that you do if you want to have your own orchestration system. But whereas if you use OpenShift, a lot of pieces of these are automated inside the tool. So we are going to cover some of those aspects as well in future sessions. That's going to be pretty interesting. So the idea here is all these Node.js tutorials are like very better tutorials than what I have done. There are a lot of tutorials available on YouTube on Node.js on Docker itself. But the idea here is get a human interaction between us to maybe have more questions and then give some inner details on how Docker works or how OpenShift works. So that is the core idea behind this meetup. So even after this call, if you have more questions on how it works, you can definitely interact on Twitter. I pasted it there, or you can put it in the chat we have, internal chat we have. So I'll be happy to answer. So this webinar is to set that ground of interaction between us, not really like, I don't want to say like I've taught something really unique, but there's a lot of tutorials available on YouTube, which are pretty good tutorials. Okay, I want you to take a look on those, and in the next sessions we will be doing OpenShift related stuff. That's when things get more interesting. How do you build containers at a large scale? How can we use containers without actually worrying about how to write a Docker file, how to make it like how to build that on your machines, how to scale those applications without worrying about load balancing and all those stuff. So that will come inside OpenShift. Probably we can set up. Okay, let me see. I've spin up a OpenShift cluster. If I can show you quickly what OpenShift can do. So yeah, so I have the OpenShift cluster up and running.
Hello.
This is, yep, sorry.
Yeah, I have a question on the memory allocation for this container. So, as you shown that the container is allocated with 560 MB, right? If the application size, the memory used by that application, which we are running in that container, if it goes more than what is allocated to that, so how it will consume from the OS, and is that taken care, or need to do it externally?
So the idea is to limit the container on how much memory or how much CPU it can use. So that is the core idea behind any container orchestration, right? So if it crosses that limit, that pod would die, sending a kill signal to the application. So the application should handle that kill signal, where daemon is going to send like, okay, I'm going to crash this application, do whatever you need to do as a cleanup process. So that needs to be taken care by the application. But if it crosses that limit, it's going to kill that application.
Okay.
Does it make sense?
And
Chakradhara, actually, hi, hello Chakradhara.
Yes.
Can we run a process management here? Actually, ports are generated dynamically, am I right?
Yes.
Can we set up a process management like clusters like PM2 or something else like that?
Sorry, I kind of missed that voice. There's some disturbance. Can you repeat that, please?
Yeah. Can we set up a process management for any application like PM2, because we have to run on more ports like a cluster kind of thing?
If I understand that correctly, can we use PM2 kind of daemons to run the Node.js applications or not? Is that what you're saying?
Yes, exactly.
Okay. So you can definitely use PM2 to invoke a Node.js application. So so is it suggested or not? That is what we need to discuss, right? So in ideal world, you want to keep one process per container. That's a suggested way. That's like a standard. Everyone does one container per process. When you use PM2, it's going to be a daemon process and also a application process, right? Do you really need a PM to monitor that application? Because when you move into a container world, it's like pets versus cattle, right? In case of pets, you want to keep those pets. Even if they got sick, you want to repair them, like your VMs, right? Even if the VM is behaving incorrectly, you want to repair that VM and then correct it, fix it. But whereas in cattle, if the cattle is not good, you just kill that, and then bring a new one. So that's like your container. So you're like VMs versus containers is like your pets versus cattle. Whether do you need a PM to really monitor that process and run it? I don't see a need for running that. But even if you want to run, you have a strong use case that you cannot get rid of PM2, you can definitely run more than one process per container. So you can have your PM2 as a starting command, the section for CMD, and then that will invoke the application process. So you can definitely have two processes per container. Is it suggested or not? That is the debatable situation. Does it make sense, whatever I told you?
Yeah, thank you.
So if you want to see
can we
like
use
what
Docker for production?
Sorry?
Can we use this Docker for production instance?
You can definitely use for production. So there are a lot of companies. So my job basically is to go to big corporates and then solve use cases based on containers. So I see a lot of interest in very major companies. So this Docker is new for everyone. Let's be honest, Docker is new for everyone. And there is a lot of adoption that is going on. And there are a lot of companies who are already running containers in their organizations. It's not that there is no one who are running containers in production. There are a lot of companies that are running containers in production, but there are a lot of other companies at large scale who are trying to adopt
any challenges. So did you see any challenges so far? So you might have gone through with all the existing ones who are using in the production. Did you see any challenges over there?
So definitely the challenge is more of a cultural change. Let's say there is a company, right, who wants to containerize their applications. There is a change in culture, like how they want to deploy their applications, how they want to develop their applications. So cultural challenge is one of the most faced by companies, and the knowledge of containers itself, like how to write a Docker file or how to containerize applications, is another challenge. But slowly I see a lot of adoption. Everyone is looking at containers as their future strategy or current strategy, cloud strategies basically. So you can think that what VMware was about 10 years ago, the Docker containers or containers in general, it need not be Docker itself, but containers in general will be like your VMs in the next few years. Maybe down the line 10 years, you will see everything in containers. That's my prediction. That's what I think most of the people think now. What VMware used to be 10 years ago is Docker now. So think of it like that.
Yeah, Chakradhara, I think we are digressing to question and answers right now. I think better we continue the show, and maybe at the end of the the presentation, I think you can ask for the Q&A questions.
Yeah, sure. So I'm mostly done on the Docker demo side. So we can have different session on OpenShift, which is good. Questions are always good. That shows your understanding of whatever I do. So questions should be okay. I'll cover some other concepts, basics on the Docker. So if I do Docker top and the container name, it shows what is the process that is running inside the container. So it is running 3 processes in this case, which may be already killed. So the one which may be active is this one, sh-e node server.js, or this one. So there is one process called PID 0 or 1. I don't recall it. So that is the core process that container looks for. So if that process dies, the whole container will be taken down by the Docker daemon. So let's say in these three processes, one of the processes is PID 0. Okay, so that's a parent process or the initial entry point process. That may be npm here in this case because npm started the other process. So when that parent process or the PID 0 dies, the container dies. So we should keep that in mind when we deploy applications. Okay. So how do you stop a Docker running containers? So I'm running 5 containers now. So do a Docker stop and give the container ID. It should stop that particular container. Okay. So stopping container will still keep the resources available, like all the disk entries that it has created. If you want to remove the container, you just do Docker rm, and it will remove everything from the disk. Okay. Some of the concepts we need to remember is, if we have this container, if you get into that container, create some file system or create something which persists on disk. If we exit that container and restart container again, you will not see whatever you have created, because when container runs, it runs in a ephemeral mode. It doesn't really persist anything that you have created. So that's how basically Docker has made that images immutable. So when you move your images from dev to QA to your production, nothing changes. So you don't need to do all the reinstall again from dev to QA to production. You don't do the reinstall. You just transfer your docs which you created in dev to different upper level environments. So only in dev you see the build process. After that, you just import that Docker binary image to the upper environment. So what is that you get when you take this kind of approach? So you get a lot of agility. So you get a lot of flexibility in deployment. So without fear, you can actually move your, you can upgrade your applications without much fear of configurational issues or maybe build time issues. All this can be avoided when you move your immutable images from dev to QA to prod in like that. Okay, so I have a very short demo on the OpenShift. So OpenShift is basically a container orchestration tool on top of Docker. So Docker runs containers in single host, right? So what OpenShift does is it creates a set of nodes and then runs containers on those set of nodes. So that's what OpenShift does. So in this example, let me go. I'm logged into the OpenShift console here. Okay. This is in this I have a demo application running, and not really here. Let me create one. So I do, when I click new project, I'm creating a dev project here, and have the option to basically choose from templates. There are a lot of templates that you can get started with. So OpenShift v2 and v3 are completely different type of container orchestration, container technologies. So v3 uses Docker images, whereas v2 uses Gears, which is a Red Hat specific containers. But v3 is more powerful and uses Docker containers under the hood. So you can create basically different types of applications. It may be PHP apps, Ruby apps, Perl apps. So if you have seen Heroku or something like that, this is similar to what a PaaS is, but it has more capabilities than what a typical PaaS is. So we'll go into some of these details in the next sessions. So this is just a small intro on how OpenShift looks like, but I don't want to get into the demo of this OpenShift. That will ruin whatever we do on the Docker now. So with that, any questions on Docker? Any fundamental questions that you want to check?
Yes. One quick question. Yeah, one quick question. Node.js, if I install Node.js on my Windows application, Windows server, so it will be around like 35 to 40 MB. Okay. Whereas in this case, when we create an image, so it's somewhere around 600 MB. Okay. So can you try to tell me the relative sizes? Okay. If it is just Node.js, it would be around 60 MB. If it is, since it's a Docker image, it is Node.js plus little bit of OS. So that's the reason it has become somewhere around 600 MB. If the same thing would have been, if the same Node.js would have been installed on a virtual machine, virtual box, then it would have been more than 1 GB. So can we is our understanding correct?
Yes. So I think you are in the right direction. So let me get into some of the layer terminology here. So you see this Node.js image, right? This is about 647 MB. The base OS, that is Debian Jessie. So it has its own OS. This is not, so the base OS which I'm using is Mac here, which may be running a VM. They may be based on a CentOS, but you are using a Node image which is based on Ubuntu. So it has copied some specific files related to very minimal without much fancy stuff in there. So it would copy very minimal base OS, like Ubuntu OS in this case, and on top of it, it's going to install Node.js, and then on top of it, it's going to install application-related npm dependencies as well. So that's the reason you see 647 MB. But the option is, if you're using the same base image and deploying, creating 100 different kinds of applications using the same base image, it's not going to create that particular image to every application image. So when I say 651 MB image here, it's really a difference of 651 minus 647, whatever, like 5 MB or 4 MB extra. That is a delta that is going to create. It's not going to create everything. So in an ideal world, you want to choose a base image and you design your application architecture such that you will use minimum number of disk space for your application. So if you stick with some base image, let's say CentOS or Red Hat image, use that base image for all your applications, and you are going to save a lot of disk space for your applications. Does it make it clear on some of the things?
Yeah,
yeah, so you notice like now, if you're running 3 instances, Docker instances, so it will be consuming only the delta of this one? I don't think so. I think it will be consuming the whole. Like it will be like 651 plus 6. I mean 3 times.
Not really 3 times. So how it works is Docker uses a technology called create on write. So only when you write something to the disk, it will create a image on it. Otherwise, it's just going to use the same disk space that you have. So if you have some time, just look at Docker create on write strategy. You will get more inner details on how it works. But to be at a high level, understand that it's not going to create copies of like multiple disk images. So it's going to only create the delta of that.
Okay. Chakra, there is one more question from the chat. It is from Sunil. He asked is it equivalent to webmin?
Is it equal to?
Webmin.
Let me check on the chat. Webmin. I'm not really sure what webmin is.
Yeah, he was trying to compare OpenShift with webmin.
So I'm not really sure what webmin is, so I cannot comment with it. I cannot compare what. I think I've used this webmin, but I really don't know what webmin is. Is it? Yeah, I can check on that what webmin is, and then tell you in the next session how it aligns with Docker container.
Okay.
So it says it's a web-based interface for administration of Unix. Yeah, this is not webmin. Webmin is just an interface UI for, right, whereas container is like a full-blown OS itself.
Hello.
Hello.
Yeah. Hello, Rajesh. Please go ahead.
Yeah. Okay. Any more questions? So how Node is installed in what OS? So it's installed basically on a Debian Jessie base image. We have installed a Node.js on top of it. So if you go take a look in the Docker Hub, look in the Argon file which we have used as a base image. It's a Jessie image, Debian Jessie image, which is again like a Ubuntu-based image. On top of it, we have installed Node.js. Okay.
Hey friends, any other questions?
Okay. We have 6 more minutes left. If you don't have any questions, we can conclude this. But you can definitely reach out to me on Twitter or on the chat window. If you have any questions in future, maybe after going through some of the tutorials online, you might have more questions. So we can definitely look into that. See one more.
Hello.
Okay.
Hello. Do you have some question for us?
Hello.
Yeah, Sanjeev.
Yep, sure.
Yeah. Can you explain me about Docker attach command attaching to a container and executing commands there?
Yeah. So Docker attach is basically like to a running container. You want to get the bash. So maybe you want to debug something inside a running container, right? So Docker attach basically attaches your shell to that running container. So it gets inside that container and gives you the bash prompt for that container. So you can go take a look inside container and debug.
Hello.
Yep.
Hello. I got it. Can you show it to all of us? I know.
So did you see the exec part?
Yeah.
Yeah, it's the same thing. So it used to be, there used to be Docker attach, and then you can use exe also to get into the command line. So let me show you that. So this is a running container, right? This piece. So you just do Docker exec and it's interactive mode, and then put the container name, and then put a bash. So you are actually inside that running container. So you can go take a look in what's inside. Maybe you want to see what's the source code that it is currently using. So you can go take a look on that. So the same thing is Docker attach as well. Is that clear?
Okay. Thank you.
Any more questions?
Yeah.
One exit from that command. Exit from the container. How to exit?
If you do exit, it will take you out of that.
Okay. Oh, that's it. Okay. Thank you.
Yeah.
So we have a Slack. Uh, we have a Slack group for all of us. If you have questions, you can post on Slack group. If you're not part of the Slack group, uh, just ping your email ID on WhatsApp. We will add it, and you can be part of your productive discussions on Slack.
Yep, that sounds good.
And thanks Chakradhar for giving us an opportunity to listen to your Docker. And the rest of the participants, we will have part 2 Docker the next month again as a webinar, and we'll be posting all the information on WhatsApp group as well as the uh, meetup. Today about 25 participants attended this webinar, except me. So I mean, the house is full for the webinar. Thanks all, and once again, thank you, Chakra. Anything you want to add to it, Chakra, please.
Yeah, nothing. So thanks everyone for joining. We'll have more sessions on OpenShift in the future. So do join those sessions. They are pretty interesting. And this is kind of technology everyone is looking forward. So make sure you also get updated with this. It may not be through these webinars, but in Docker in general, you have a lot of help online to basically on Docker and OpenShift itself. So go take a look. If you want some help on the webinar sessions, you can join here. So in any way, I think containers are our future. So let's make sure you are up to date with that. Thanks everyone for joining.
Thank you all.